Welcome back, guys. अब हम करेंगे reflection and refraction of light. Question 6, paper 2, 5054. Let's start. Question 6. Three angles of a glass prisms are 45, 45, and 90 degrees as shown in figure 4.1. At point Y, a ray of light or a ray of light of a single frequency travels in air and strikes the side of the prism at 90 degrees. The ray passes into the prism. The light travels more slowly in the glass than in air. State what happens to the wavelength of the light in the ray as it enters the glass. अच्छा, एक common formula है V is equals to F lambda. ठीक है ना? अच्छा, अगर velocity कम होगी then the lambda which is the wavelength ही लिख लेते हैं. Wavelength. If the velocity is decreased, the wavelength will decrease. ठीक है ना? While on the other hand, if velocity or either wavelength are decreased, only these two will be affected. The frequency will remain constant. The frequency will not change if either wavelength or velocity have changed. ठीक है ना? तो फर्स्ट ऑफ ऑल यू हैव टू रिमेंबर दिस. अब आप अपने दिमाग में तीन चार दफा इसको रिपीट करें. इफ द velocity is decreased, the wavelength will decrease. If either of them are decreased or increased, none of the frequency will be changed. Frequency will stay constant. So the only two variables are varying factors are velocity and wavelength. And if either of these two are decreased, the other one will decrease as a result. ठीक है ना? If, for example, velocity is decreased, wavelength will decrease. If velocity is increased, wavelength will increase. While f being the component which is going to stay the same at all times. अच्छा, आगे. State what happens to the wavelength of the light in the ray as it enters the glass. It is gonna decrease. The wavelength is gonna decrease. Decrease. अच्छा, आगे देखते हैं. State what happens to the frequency of the light in the ray as it enters the glass. As I just told you, frequency will be the same. आगे चलते हैं. The refractive index of glass is 1.6. So refractive index हमें क्या बताता है? The how much the light is gonna bend. Calculate the critical angle for light in glass. Critical angle हम इस formula से निकालते हैं, which is n is equals to 1 by sin c. C will be the critical angle, refractive index will be n, and 1 will be used in the equation. n हमारे पास है 1.6 is n is equals to 1 divided by sin c. C will be the critical angle. अब हम इसको calculate कर लेते हैं. Sin c को हम वो कर लेते हैं, what do you call it, make it the subject. तो 1 divided by 1.6, it will give us sin c is equals to 0.625. अच्छा, यहाँ sin c दूसरी साइड पे जाके it will be inversed. तो c is equals to sin inverse sin inverse 0.625, which will give us an answer of approximately 39. ठीक है ना? तो that would be the critical angle. क्रिटिकल एंगल का ये फॉर्मूला भी आप याद कर लें. पॉज करके अभी याद कर लें सुकून से. यू हैव प्लेंटी ऑफ टाइम. सो आगे चलते हैं. ऑन फिगर 4.1, sketch the path of the light after it strikes the side of the prism at Z and after it returns to the air. तो बेसिकली मैंने आपको सबसे पहले क्या बताया. When you are doing a calculation like this, first make a normal. नॉर्मल बना लीजिए. नॉर्मल बना लिया. So this will be the angle which is being angle of incidence, or this will be the angle of reflection. So as we all know, angle of incidence is equal to the angle of reflection. तो हमने सिर्फ एंगल ऑफ इंसिडेंस निकालना है, तो एंगल ऑफ रिफ्लेक्शन हमारे पास दोनों तरफ आ जाएगा. तो एंगल ये 45 है, दिस इज 90 बिकॉज दिस इज राइट एंगल. तो 90 ये आ गया, 45 ये आ गया, और फिर दिस विल बी लेफ्ट 45. और अगर 90 में से 45 and this whole angle is 90, so 90 minus 45 will give us 45 again. So this angle will be 45 again. And if this angle is 45, the reflected angle will be 45 as well. So this is gonna go like this. Let's go on to दूसरी से. And it is gonna exit the light at no angle. चलो जी. The angle of refraction will be 0. So yeah, that is the answer of this video. I mean, that is all. That is it for this video. I hope you enjoyed. Have a great day. Allah Hafiz.